Hello students, this is your computer teacher, and today we are going to start with a chapter named Computational Thinking. Before we get into the details, let's check an overview of what are we going to learn today. What is computational thinking? That means it will include the basic introduction of what computational thinking is. What are its components? How do they work together? Why computational thinking is important. So without further delay, let's get straight to it. Computational thinking means to take a problem, analyze, or approach it systematically to find a solution to it in a step-by-step process that can be carried out by a computer or a machine. You might think that computational thinking is about thinking like a robot or an expert, but it's not. Rather, it is just a problem-solving skill which changes the way you look at complex problems and find solutions to it in a more easy and efficient way. Let's go a little deeper and find out about the components of computational thinking, which allows us to find a solution to a problem that both a user and a computer can understand. So basically, there are four components of computational thinking that work in order to achieve desired results. First one is decomposition. Number two is pattern recognition. Number three is abstraction. Number four is algorithm. In certain situations, number two and number three, that is pattern recognition and abstraction, can be done simultaneously. So before I define these terms, let's take an example that will feed you the concepts of these and make you understand them better. Now the problem here in hand is that I want you to add all the numbers between 1 and 200 in your mind. So you can start now, and let's make this activity more interesting by giving you 30 seconds to complete this task. And your time starts now. So 30 seconds are up. Let's come back and see how many of you are able to solve the problem. Here are a few questions for you. How many of you thought it's impossible to add all the numbers from 1 to 200 in just 30 seconds in your mind? Now the question number two that comes up is, how many of you tried at least? Well, if you tried, clap for yourself, as you deserve it. And if you didn't, well, then in next 30 seconds you will learn how to add them. So by using computational thinking, I am going to teach you how to solve this complex problem easily and efficiently. Let's take a look. Here's what we need to do. We will add all the numbers from 1 to 200. If you look closely, you will observe that 4 plus 197 is equal to 201. 3 plus 198 is equals to 201. 2 plus 199 is equals to 201. And fourth, 1 plus 200 is also equals to 201. So each time the result becomes 201. Now count how many numbers we have added till now. 1, 2, 3, 4, 5, 6, 7 and 8. So total of 8 numbers. So 8 numbers, and now let's count the number of boxes. 1, 2, 3, 4. So we have added 8 numbers in just 4 steps, that is half the number of steps. So the total numbers that we need to add are 200. From 1 to 200 there are a total of 200 numbers. So if we divide them by 2, we'll have 100 steps. And each step is giving us an answer of 201. So we'll multiply 201 with the number of steps, that is 100, which gives us the result, that is 20100. It's as simple as that. So what we just did is we broke the problem into smaller pieces. That's called decomposition. And then we recognized a pattern from that. And finally, we formulated an algorithm that gives us the result. Let's define these terms one by one. The first one is decomposition. Decomposition means breaking down a problem into smaller and much simpler steps. As you can see in the pictures, making a big puzzle is a task. But when number of people are dividing the entire task into smaller, simpler tasks, the much bigger problem becomes much easier. So moving on, the next step is pattern recognition. Pattern recognition means finding similarities between the things separated using decomposition. Now, decomposition will break the bigger problem into smaller problems. Now, we will use pattern recognition to find the similarities between those broken pieces. They always will be interlinked with each other through similarities. We just need to find out those similarities. That is how we are going to use our brain to find the solution to this problem. Now, the next step is abstraction. Abstraction means finding and taking variations or differences out of the pattern to make it fruitful. I'm going to explain you by giving an example. Like, I have written 2 sentences here. First one is I am playing cricket, second is I am playing football. Now we have to find the similarities between these two, that is I am playing is written in both the sentences. So this phrase is common. So I'm going to write that phrase as a template because it's common in both of them. But what is changing is a type of sport or a game that I am playing. That is cricket in the first sentence and football in the other. So I'm going to leave a blank for that in a template so that if I am playing any other third game, let it be tennis or golf or any video game, I can write that. Simple as that. Now the final step or the component here is algorithms. Algorithm is a set of rules followed to solve a given problem, especially by computer. Now in algorithms, we give instructions to the computer on how to do a particular task. Let me explain this by giving an example. Now the problem here at hand is how to make a tea. We'll break the problem into simpler steps, find a pattern, and then give instructions to the computer on how to solve the problem. So step 1 will start the process, whereas step 2, a simple instruction is given to the computer that puts some water in a pan. In step 3, we will heat the pan using a gas or an electric induction. Step 4, we can add tea leaves and sugar into the pan. In step 5, we'll boil it, and when we'll stop the process, we'll have the desired result. That is, in this case, we'll have a tea in our hands. Finally, we'll move on to why this computational thinking is important. Computational thinking helps build skills of problem solving amongst learners. It helps looking at a challenge in a very productive way. As you realized at first when I asked you to add 1 to 200, the numbers between 1 to 200, some of you didn't even try. But since I have explained you how to do it, now the next time if someone asks you, add the numbers between 1 and 500, now you will at least try. Now, why that happens? Because you have started to look at a challenge in a very productive way. It develops persistence in working with difficult problems. In the same way, it sharpens the ability to communicate and work with others to achieve a common goal. It also helps in predicting best possible outcome, which might be even improbable theoretically but can be achieved using computational thinking. Let's wrap it up that computational thinking is nothing but a problem-solving technique where you think like a computer and solve very complex problems in no time. Now it has 4 basic components. Decomposition, that breaks bigger problems into smaller ones that are easy to manage. Second is pattern recognition, when you analyze and look for the patterns or similarities between those broken pieces. Third one is abstraction, that removes the differences or variation. And the fourth one is the step-by-step instructions that we give the computer on how to solve a problem and to reach the desired result. So with this, we complete this chapter of computational thinking. I hope you enjoyed it and learned something new. If you have any doubts, you can reach out to me. Thank you. Stay safe. Stay healthy.